Hello everyone, and welcome to this demo for Docker for AWS. So I have a button over here that will launch a CloudFormation stack right away. So I'm going to click that. This will open my AWS CloudFormation console and we'll have the beta CloudFormation configuration ready. So I'm just going to quickly go into the designer over here. There's instances, there's policies, load balancers, auto-scaling groups. Just going to create a stack. So we click next. Now we'll have to add some configuration. So a stack name, I'm gonna name it Docker for AWS. Then I'm asked the amount of swarm managers. And obviously since they need quorum, it's 1, 3, or 5. So I'll stick with 3. And I'll add 3 worker nodes. For the managers, I'll go for small nodes. The workers can stay at micro, it's fine. I don't have heavy workloads to go today. And set up my SSH key that will be used to log into to these instances. I go next. I can add some key values here, some naming, some stuff like that. Not going to do that today. Just going to leave everything by default. Go next. Here I see an overview of what I'm going to set up. So it's just all the configuration I've put in there. I acknowledge that CloudFormation can make some IAM resources. I'm fine with that, and I go on and go. All right, and we're back. So this process took about 10 minutes. So let's see what happened. The CloudFormation created lots of resources. Okay, so more importantly are the outputs. So we want to be able, obviously, to connect to our managers. And later on, when we launch a couple of applications, we need a public endpoint, of course, public DNS, to get access to them. And so let's get started by logging into one of the masters. So in the output, you get an SSH command over here, which I'll copy paste. Go into my terminal. Okay, so now we're logged in to one of our managers. So just to be sure that Docker is running, Docker info, and here we can see a lot of information about our Docker installation. Not only that it's running and that Docker is installed, but there's a swarm active. This node is a manager, obviously. We asked for 3 managers and in total 6 nodes. Add the 3 workers to that. Bunch of basic installation. Maybe an important thing is that by installing Docker for AWS, the default logging driver is AWS logs. We'll tap into that later, see how we can get to our logs that applications are generating, and lots of other stuff. Just gonna run the hello world container to see if everything is working as intended. All right, you can see it over there. It was pulled in, some things were executed, and it's the basic Docker hello world command that you can see there. All right, but as I said, we have a swarm mode installed, so just gonna check on our nodes. So there's a primitive command docker node, which I will list and see. Okay, we have six instances running, of which 3 are managers, and 1 is obviously the leader, and I'm connected to one of the hot managers. Then I get this nice little visualizer that we'll use further down this demo, in which you can see all the nodes in our swarm. The ones with the 2 GB RAM are the managers, of course. Those were small instances. The workers have 1 GB of RAM. And for now, I have 1 replica for the visualizer running that I specifically requested with a constraint to say, okay, only run on a manager, which is the case, obviously. All right, so that's nice. Cool. So next is our application, of course, and probably many of you already know the application we're going to run. It's the voting app that Docker uses more often these days to showcase some of their features, so I'm just going to use that application. It's an entire application stack, basically consisting of 5 different components. There's 2 front ends. one Python and one Node.js application. The Python one is the voting application, so where our users are going to be able to vote on two choices. And on the other hand is the manager part, let's say, the resulting app to see how the voting has resulted in what percentage each vote has gotten. The voting app will push every vote in a Redis queue, where a worker is listening to this queue and will push every vote into a Postgres database. And it's this Postgres database that the result app will use as a storage to show its results. So very modern stack, very decoupled, very loosely coupled. So very interesting to work with, all different kind of application, programming languages, DBs and sorts. So it's a very modern stack. You can check it out in the Docker example voting app repository. There's also a Docker compose in there that will entirely set this stack up. And so this is the application that we're gonna run in our Docker for AWS environment. So to do that, I'm going back to my manager, and let me open the visualizer. So as soon as things change, we can see them change underneath. So first thing I'm going to do is create a specific network, and our entire stack will run on two networks. We'll create one network for the voting side of things, and we'll create another network for the result side of things, because we don't want those side of the application or of the application stack to interfere with each other. They don't have business with each other. It's only the worker that will sit in between them. So first, I'm going to create a network, which since 1.12 is also a primitive in the Docker CLI. So Docker network create. And I want this to be an overlay network, meaning that the entire network needs to span over my entire swarm. So I want to be able for containers to connect to each other without having to worry about what container is running on what instance underneath. I don't care about that. I just want my applications to easily be able to connect to each other. So I use the overlay driver and I call my network vote. All right. If I now check the networks available, so there's a bunch of networks that are by default provided by you, but here all the way underneath we see my voting network, which has the overlay driver and will run in the scope of my entire swarm. So that's important, because I want to be able to spawn containers for my application everywhere on whatever instance, and they need to be able to connect to each other. So that's nice. Now obviously the service itself. So I'm going to start with the voting side, obviously. Service create. On the vote network, I give it the name vote app. I want to publish the application on port 8080, but in the container, the service is on port 80. And I run the Docker image, Docker example voting app, and it's the vote part. All right. Cool. And underneath there in the visualizer, you already see things happening. So on one of the managers this time, it doesn't matter, there was a container spawned that I requested, and it's the example voting app vote part. So it's just one replica, of course, not very fault tolerant. So just to also get a look on this from the CLI side of things, I check, okay, I have a new service vote app in my swarm, one replica. I can dig into that deeper by doing a PS on the vote app to see what container is running and where. So it's this container with this ID on this node, and so on. But as I said, this isn't obviously very fault tolerant. We're expecting a lot of visits on this application, so I want to scale it a little bit. So I say Docker service scale vote app, and I'm going to request 6 containers for this application, 6 replicas. All right, and again on the visualizer you see things popping up. So 5 new containers are being spawned everywhere. I didn't set any constraints, so they're just going to try to spread itself as nice as possible. All right, so if all is well, we should be able to connect or to visit our voting app. So again, I go to the public endpoint. which I copy pasted from the CloudFormation outputs. And as I said, it's running on port 8080. And there we go. There we have our voting app. Now, for now, it won't work because it's just the application. There's no backend. So when I click this, obviously, we get a server error for now. I'm going to fix that in a minute. And as you can also see in the load balancer, when I refresh this, another port was added, 8080, for this new application. All right, let's get this thing to work. So we need another service for the queue. So Docker service create. Also on network vote, because yeah, the vote app needs to be able to connect to this Redis, so they need to be on the same network. Give it a name Redis, since it's a Redis queue, and run this from the official Redis image. There we go. Docker service list. Okay, Redis is spawning. I'm gonna refresh this page. And right over here, our Redis by now has been spawned. So I'm going to rerun this command. Okay, one Redis, six vote apps, and the visualizer. That's what we expected. Go back to our application. I vote cats for now. And now we can see, okay, it's working. The Redis has picked up my vote. No errors or anything. That's very nice. Now, another thing that's important to mention over here is the fact that since we said there is 6 containers for the voting application, obviously I need to be load balanced, which is something Swarm mode will do for you under the hood. So as you can see over here, the application is showing me on what container ID I am getting service. But if I refresh this page a couple of times, you'll see that the container ID will change. Maybe 1 in the beginning, C5, and so on. So the load balancer internally will push me to whatever container of the voting app when I go to port 8080, the one my service is public on. All right, now for the backend of our system, gonna create a new network. So Docker network create, and this time we're gonna name it result. Sorry about that. It's this way I should do it. So again, an overlay network that spans on our entire Docker Swarm cluster. Driver overlay with the name result. Okay, I'm gonna check if it's listed. Okay, there's a new network named result overlay driver on Swarm. That's what we wanted. Okay. Now, I'm first gonna launch the Postgres database for this, and one other feature that I would like to highlight here is the option to label your nodes. So let's say, okay, we want this Postgres to run on the instances that have SSD disks. So just to mimic this, I'm gonna check one of the nodes, just gonna pick one, let's say this last one, and I'm gonna label that one, Docker node add label. No, sorry, that's incorrect. It's label add, and I'm gonna say that this should get the label disk SSD key value. This is the ID of that node. Sorry about that. Oh, I need to update this one. Docker node update. All right, adding a label. Cool. Okay. Now our Postgres database. So it's another service that we're gonna launch. Create, name it DB on network result, and with a specific constraint, as we did earlier with the node managers. So the node should have a label called disk, and that should be equal to SSD, and launch from the image Postgres. Okay, launch this service. All right. So as we can see here, it's the one with 179, and in our visualizer, okay, Postgres is loading over here on the instance ending in 179, so the one we labeled with the label, the disk label SSD. Great, that's what we expected. So now let's launch the service itself. Docker service create again, on network result. That's where our Postgres is. Immediately gonna set an amount of replicas. I can also label the service, so not only the nodes can be labeled, but the service can also be labeled. So just for sake of trying it, I'm going to say the app type is a front end. And this could be used for instance, if you have specific, I don't know, log shipping logic, and you want to sidecar a log stash or a log shipping container that only needs to listen to front-end applications, then this is a way of doing that through constraints. All right, name it result app. This time I'm going to publish it on port 8081. In the container, it's exposed on port 80. There's also another port that we need to open, 5858. I'm going to use the exact same port. And then the image that we can find over here. Launching the service. All right, so there's an extra service over here, result app. And if we check over here, we see a bunch of new ones popping in over here. They're launching, still red, coming up nicely, green over here. And these guys will come anytime soon, I guess. So let's visit port 8081. And there we go. So no votes have been put in the DB up until now because the worker is not yet running. So yeah, 0 votes means 50-50 for now. So let's then do one more thing, and that's launching our worker. Okay, Docker service create. And this time the worker needs to be able to connect both to the Redis and to the Postgres. So needs to be on network vote and also on the result network. We expect a lot of traffic, so let's have 2 workers ready for that. I'm gonna name this application the worker, and we'll launch from the worker image. There we go. All right. 2 workers over here. Great. They're launching a bit heavier images, so it takes a little while. I'm gonna check the service itself, PS worker. So they're preparing. Give it a little time. Okay, running. They're running. Both green. Great. So if all is well, then I go again to my voting app, and I vote for cats. Underneath, you can see my 1 vote is casted. Cats are over here. I go in another window. Oops, that's not what I wanted. So cats versus dogs. I want this one in an incognito window. So this guy is also a cat person. If we go back to our other application, we see 2 votes, 100% for cats. All right, that's great. Now, so, okay, this voting has been running for quite a while, very nice results, but a new marketing campaign has come up, so we want to do an update to this application. So what I did was, or the request was to vote for Star Wars versus Star Trek. This is the change I made. I already pushed it, built it and pushed it to my own repository. So now I want to update my application. So what I'm going to do is Docker service update, because I want to update the service. Let me open the visualizer already so we can see things happening. But to make it very visual, I'm going to put an update delay of 30 seconds. And I'm going to update the containers. So there's 6 right now in pairs of 2. So update parallelism is 2. So in pairs of 2. And I want a new image, which I can find over here on my own repository, my vote app, the sci-fi tag. And it's obviously the voting app application that we want to update. All right. So what you're going to see happening right now is that 2 by 2, the voting app vote is going to be relaunched. So these two have been updated with the new version. The other ones will follow after 30 seconds. And so if we keep refreshing this thing, we'll eventually end up on some of the cats and dogs. Well, here's the Star Wars and Star Trek already. If I refresh further, eventually all of the applications will be updated to this new version. Still the cats and dogs here, but slowly the rolling update will be rolling out, and in the end, all the containers will be Star Wars versus Star Trek. Cool. All right, let's assume now, okay, the ops department needs to do a change. There's a kernel update or something needs to change under the hood. Obviously, we're not going to bring the entire infrastructure down. We're going to do that one by one, but we want a graceful exit of our applications and move them to other nodes, so I can entirely drain one node, make it not accept any new tasks for now, do my updates, and bring it back. So what I'm going to do is docker node and update that node, set its availability to drain. And let me take, if I go back over here, let's say the 178 over here, that's this one. I'm gonna drain that node, should be the first one on the visualizer. Well, you could already see it. The node is being drained. It was only one container running, but by now it's not running anymore. And when we refresh a bit, we see that it's now pushed over there. I can do my updates, make my changes to this node, shut it down, bring it back up, reboot it. Everything will, until it's back. So now my job is done, and I'm gonna make it available again. So availability active for the same node. It's active now, and when I say, okay, Docker service scale, result app, also to 6. If all is well, we'll see that this node is being populated again. All right, so that's great. That's how we can do maintenance. Now, one more thing is, and this is something that I see a lot of questions about on the community fora and in the issue trackers, is, okay, how I want to run a specific container on all the nodes in my system. Okay, there's a way to do that. So it's also as a service that you're going to create. And just to make it easy and easily checkable from a browser, we're going to launch an Nginx, a basic one, and make it public on port 80. But there's one specific setting now that we need to do, and set it to mode global. So this is a global service, which means it will run on all the nodes in my system with the Nginx container. And when I launch that, you'll see that on every service, one by one, on every node, one by one, Nginx will start spawning. So there's one here, one here, one here, one here, one here. And we can see that more easily from the PS of this service. See, we have 6 nodes, and there's one service over here, a global one, that run on all of these 6 nodes. All right, just to make sure that it works, we go to port 80, and we end up on an Nginx. All right, that's great. So in the beginning, I showed that by default, the CloudWatch or the AWS logs driver is set in our Docker runtime, meaning that if you go to CloudWatch logs, you will see that all our container logs are over here. So there's a group Docker for AWS. That was my the name of my entire stack. And when I go into that, you can see the log streams of all the containers that have been running. So just gonna check one. You'll see that, yeah, this is the access logs for a certain container, and can, for instance, do this. And in the last 30 seconds, when I refresh this a couple of times and refresh this too, you'll see that the requests I've done to this Nginx nicely end up into this CloudWatch logs. So this is all my browser activity that's being logged. So it takes a couple of seconds to be picked up or to end up in CloudWatch, but you can nicely follow your logs going into CloudWatch logs. All right, so that concludes this demo of Docker for AWS. So if you want to try this out, make sure to subscribe or to leave your details on the beta.docker.com page, which you'll see over here. And if you want to get more information and how to set things up, obviously you can go to the docs AWS page where everything is explained. Hope you liked this demo. If you liked it, please give me a like and subscribe to this channel. We try to give more demos about things like this: Docker for AWS, Docker Cloud, Docker on Azure, Docker Swarm, all sorts of stuff. So yeah, subscribe to get updated on new videos, new demos, and thank you for watching.